you need more space, yeah, you can go up. I need somebody to do the middle one. Let's see who else is. I'm gonna have you do the second part.
Stand up.
So for this one, would you go into B or B?
It doesn't matter, you should get the same thing.
Okay.
Make sure you check one of your problems in the chart to make sure that it works. Check one of your x and y values. And by check, I mean you pick one of the x's and you plug it into the formula and then see if you get the y that you were expecting to get. If you didn't, then you must have done something wrong to find out what it was. All right, let's go over these. If you've gone onto the back, go back onto the front, and we're gonna go over these together. All right, the first one, we have 12 equals 4x plus 2x. What is the property that we're doing for this first step, putting them together? What is that called? Does anybody know? What property are we doing to add these two together? Can you give up? It's called combining like terms, because this has 4x, got an x, and this has an x. 4x and 2x, you can put them together because they have like terms. They both have x's. So that equals 6x. And then you're dividing by 6 on both sides, and x equals 2. To check it, if you weren't sure, just to make sure, you plug that into x, and you say 2 times 4 is 8, and 2 times 2 is 4. 8 plus 4 is still 12. All right, next one. What property is this that we're doing?
Distributive property.
You're right, distributive property. These ones don't have like terms. This one has an x and that one does not. So you can't just put them together. So this, when you have two parentheses out there, that means you have 3 of these groups. So you're multiplying them together. 3 times 2 is 6. Good, and 3 times 5 is 15. So, and don't forget that negative. And equals 15. Good? What do you do next? You still don't have combined like terms. So what's next? Evan, what do you do next when you have this 6x minus 15 equals 15?
You add 15 both sides.
Mm-hmm. Good, and you got 30. So 30 equals 6x. All right, Mackenzie, what do you do next?
Then you divide 6 by both sides.
Mm-hmm. Good, because if you put it to one side, it's to the other. And then you got 5x. 5 equals x. Good. All right, the next one. So how is y changing? How much is it changing by?
10.
By 10, right? So that's the change in y. Does anybody remember what vocabulary word we called that?
Coefficient.
Yes, the coefficient. The coefficient is the number that's right in front of the x. And then what would our constant be? 2. And that was when x is 0, y is your constant, and that's 2. So when we wrote our formula, it's 10x, that's your coefficient, plus 2. All right, and then to see if it works, you plugged it in and see what did they pick. They picked 0. They picked the first one. It'd be nice if you picked, you could pick any of them. It'd be nice if you picked maybe a different one, but we already know that it's going to work, so right? Because you're going to find 2. 10 times 0 is 0. Easy math, right? And you got 2 as a result, and that's just what you were expecting. All right, the next one. How it's changing by -3. How come negative?
Because
The number's going down.
Yeah, it's going down. So it's a negative. And then, so that's your coefficient. All right, and then your constant we're not given what 0 is, so you had to find it. How did you get 9? Yeah, since you're going back the other way, you have to add 3 to get 9. Good. So our formula is negative 3x plus 9. That's where you get your numbers from, and that's your formula. And you plugged it in, 1 to check. 1 times negative 3 is negative 3, plus 9 is 6. And that's just what we were expecting. Good. All right, last one. What's the change in y? It's going up by 3? Well, first, what's going on this side? What's happening? It's going up by 6, right? All right, and what about this side? This side's not going up by 1. It's going up by 2 on each side. And we are given 0. What x equals 0, y is 6. So let's see what we got for our formula. We got y equals 3x plus 6. Let's see, did that work? They plugged in the y. In our formula, this is x. You got to use, we had this y. Okay, you did that one. All right, 3 times 6 is 12. They skipped a step here. Might use a different color. 3 times 6, what's 3 times 6? It's not 12, 18. 18 plus 6. So it worked. But did somebody else get a different formula? Oh, let's see. This 3 is different than this 6. How come?
Because the x value skips by 2.
Oh, it skips by 2. So what did you do?
So you would have to find half of 6.
So you have to find half of it because it's going up by 2. So like if this was 1, then this would be
9.
9? You guys agree? Alright, so that's how you got the 3, because it's a little tricky, isn't it? Alright, you got it right. Good. Alright, before you guys finish this classwork, I will collect it, but we're going to have a quiz. So we have been doing very good on our quizzes. This is our 3rd quiz in a row, and you guys have been almost all acing it. So I made a harder quiz. So on this quiz, you're still going to be doing the things that we've been learning about slope, about positive and negative slopes. How do you know which one is positive and which one is negative? So if it's going from right to left, just like you read from right to left. If it's going uphill, is that going to be a positive or negative slope?
Negative.
It's going uphill. Uphill is going to go positive. If you're going downhill, from right to left, you're going downhill. Down is negative. You're decreasing your values. It's going down. What if it was this way? What if it was flat?
Neutral.
So what would your slope be?
0.
0. There'd be 0 slope or no slope. Your slope would be 0. What about this way? If it was straight up and down, a vertical line, what would your slope be? Well, we talked about this at the end of last class. What do you think it would be? Maybe I should write it down. You guys forgot. All right, let's see. So if it was positive, going from right to left, positive, that's a positive slope. If it's going downhill, we're going from right, we're going downhill to left, that's a negative slope. And a straight horizontal line, what was the slope?
No slope.
The 0 or no slope. What about if it's a vertical line?
Undefined.
Yeah, it's undefined. Ha, you remembered. Undefined. Remember we were doing like a bike? Like if you're biking uphill, it's a lot of work. Biking downhill, you're going fast. You can bike. But if you biked that, you would die. Don't bike that. That's undefined. That's not allowed. You're not allowed to bike undefined. It'd be a cliff. Alright, so that's undefined. So when you're finding the rise of a run, you're not rising anywhere, right? You're just running. So then your fraction the rise would be something like this, over some value. Well, what about this one? What would the fraction look like? There would be some number up here, over 0. In math, you can't have 0 being on the bottom. That's why it's called undefined when in slope. A 0 is just not allowed to, like if you had a fraction like of a pie, you cut it into slices, you had 1/4 of maybe a brownie or something, you can have that. You can have no brownies. There's still brownies there, you're just choosing not to have them. Maybe you're on a diet, I don't know, that's fine. But you can't eat brownies if you didn't make them. You can't have a brownie of when there's no pan. It's just not, it's not possible. So it's undefined, not allowed. All right. See, did we cover everything? All right, did we cover everything? Oh, I have one more thing to say. If it's like 50 degrees outside at the beginning of school, but then like at 7 o'clock, maybe. At 7 o'clock, maybe it's 40 degrees. If it goes up by 10 degrees, if it gets hotter, how hot is it? It's 60 degrees at 7 in the morning. How hot is it going to be at 8 o'clock, 7 o'clock? If it's at 8 o'clock, if it goes up by 10 degrees, how hot is it going to be? 70, right? So you're starting at 60 and you're going up to 70, right? So you could almost graph that on a line as on your chart. That would work. That would have a positive slope because it's going up. And the evening would probably have a negative slope as it's going down. All right, separate your desks.
I have a question. What
Oh.
was the formula that you used to check if the slope is correct?
To check, you plug in one of your values and see if you're getting what you're expecting. Just like this. You're plugging in one of the values and you see if you get the y value that you're expecting.
Did you say it was like one of your pictures or something? I don't know. I don't think about it.